Okay, here's your idea. In an arithmetic sequence, and I know people don't like to use words that they feel like they might mispronounce. So would you please turn to the person next to you and take turns saying arithmetic twice each. Okay, that sounded like it. Okay, so in an arithmetic sequence, the difference between consecutive terms, and when I say the word terms in an arithmetic sequence, I just mean numbers, is constant. We'll look at an example in a moment. This constant value is called the common difference. Okay, so there's your vocab. Here are some examples of arithmetic sequences: 4, 6, 8, 10. Okay, notice that you have a common difference of 2. How do you find a common difference? You take any term, like this one right here, and you subtract, that's what difference means, the previous term, that one there. So 6 minus 4 equals 2. Question? Oh, yeah, okay. How do you specify if you're adding to or subtracting to? Is that your common difference is positive, you're adding. If your common difference were negative 2, this sequence would be 4, 2, 0, negative 2, negative 4. Okay. So we refer to this as the common difference. If it's positive, you're adding. If the common difference is negative, you're subtracting. Thank you. Okay, so this one here, 26, 23, 20, 17, 14. What's your common difference?
Negative.
Okay, so we took any term. I'm going to take this term right here, the last one, and I subtract the previous term, and I get negative 3. Okay, we're going to have to get some notation to keep track of all the terms. And I don't want you to get confused on something so simple as the notation. So I'm just going to put an example of an arithmetic sequence up here. An easy one: 2, 4, 6, 8, 10, 12, 14. And we could keep on going all the way up to, let's say, 100. Then the very first term I call the first term. And I call the second term the second term. And I call the third one the third term. And I call this the fourth, the fifth, the sixth, the seventh term. And I denote it like this because I don't want to keep saying the first term. I put T with a little subscript of 1. And it's not written like this. It's written like this, subscript. Okay, so make sure you get your notation correct. Then this one is term 2, and this one is term 3, term 4, term 5, and you could keep on going. If we don't know what number it is, we just say T sub n, and we just use an n for any integer. Okay, so I'm going to give you a formula for finding the common difference using this kind of notation. I say this: the common difference is any term minus the previous term. And it looks complicated, but if this were my series, I could pick any term, like term 4. Subtract the previous term, which would be term 3. Are we seeing that? Okay. What if all the numbers in an arithmetic sequence are not given? So, like the question I gave you in the warm-up, I'm missing a couple. I know this one, I know the last one, but I don't know how many are, I don't know what the two terms in between are. So let's just start by labeling this. 11 is my first term. That's my second term, which I don't know. That's my third term, I also don't know. Here's my fourth term. How am I going to find the missing numbers? Well, I could say this. If I went from 11, term 1 to term 2, I would have to be adding my common difference. From term 2 to term 3, I would have to add that common difference again. From term 3 to term 4, I would be adding that common difference. I know it's a common difference because it said arithmetic sequence. Okay. So if I started at term 1, which is 11, and I added 1, 2, 3 D's, I would end up at 35. And I know you can all solve that. Subtract 11 from both sides, and I get 24. Divide both sides by 3, and I get D is equal to 8, which tells me 11 plus 8 give me 19. 19 plus 8 gives me 27. 27 plus 8, check. I got the 35. So we're seeing that process. So I knew term 1. I added 3 times the common difference, and I ended up with term 4. Do you see how this algebra works? Okay, let's get familiar with terminology as well. So 4, 7, 10, 13, 16, 19. Our first term, term 1, is equal to 4. Our second term, term 2, is equal to 7. Our common difference is take any term, subtract the previous term, you get your common difference of 3. If there's a dot, dot, dot at the end of the sequence, that means it just keeps on going forever. We call this an infinite arithmetic sequence. Okay, I've got a little graph here to represent an infinite arithmetic sequence, and I've graphed it. So my first term, I'm just graphing the term number. First term is 4, second term is 7, the third term is 10, the fourth term is 16, and you can see I've got a scale here of 4. Oh, sorry. 4, 8, 12, 16, all the way up to 20 there, so I've got 19. And you can see that the graph represents a linear function because the points lie on a straight line. And a line through the points would have a slope of D. What's my common difference? 3. Right, if I go up, oh, that's going to be really hard to see with this kind of a scale. From 4 up 3 would bring me to 7 and over 1. From 7 up 3 would bring me to 10 and over 1. There's my slope. In an arithmetic sequence, the common difference can be any real number. Okay, so a common difference could be a fraction. It could be pi, 3.141, blah, 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 blah. Increasing arithmetic sequence, we have an increasing arithmetic sequence if D is positive and the terms are getting bigger. You will have a decreasing arithmetic sequence if D is negative and the terms are getting smaller. Okay, so here's an example of increasing. 2, 7, 12, 17, 22, dot, dot, dot. What's D? Do you even need to show the algebra? No. Here's an increasing arithmetic sequence. 1 over 2, 3 over 4, 1, 1 and 1/4. It's getting bigger. It's increasing. What's D? And what would have been the easiest one to work with? Probably the difference between these two. What's 1 1/4? Subtract 1 leaves you with 1/4. If you did these two, then you had to have common denominators. Okay, 74, 64, 54, 44, 34, dot, 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 forever. What's the common difference?
10.
Is it 10? It's negative 10. Saying 10 is actually wrong. Yeah, you should be. Negative 1, negative 7, negative 13, negative 19. What's the common difference? And those are all decreasing. Why? Because D is negative. Okay, think about this arithmetic sequence. 3, 7, 11, 15, 19, 23, dot, 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 dot. We're going to try to come up with a formula for writing down the general term. By general term, I just mean any term in the sequence. So if I wanted to know what's the 30th term, I don't want to keep on adding, well, I can see the difference here is 4. I don't want to keep on adding 4 until I get to term 30. I want to just calculate term 30. So we're going to come up with a formula for that. So term 1 is 3. Term 2 is 7, as in 3 plus 4. Term 3 is 11, as in 3 plus 4 times 2. Term 4 is 15, as in 3 plus 4 times 3. We seeing the pattern here. It depends on your first term and your common difference. So you're always going to start at your first term, and then you're going to add how many common differences do you need to get to the first term? Well, you don't need any. How many times do you have to add the common difference to get to the second term? Once. You start at the first term. How many times do you have to add the common difference to get to the third term? Once, twice. You start at the first term, and how many times do you add the common difference to get to the fourth term? 1, 2, 3 times. So your formula is term 1 plus D times n minus 1. For example, if I wanted to know, and we'll just use one of the terms we've got, 1, 2, 3, 4, 5. Let's find term 6 using this formula. Term 6, so I let n equal 6, is term 1 plus D, and my D value is 4, times n minus 1. What's my n? 6. So term 6 is equal to term 1, which is 3, plus 4 times 5. Does it give me the right answer? Did you get 23? Okay, so that's the formula that we're going to be using. I will not make you memorize this. I'm going to give you a cheat sheet for every quiz and every test you write. And it will have that formula on it. However, you're just going to know it by the end anyways. Okay, to determine the expression for the general term, and how do we denote a general term? We say term sub n, the nth term. Use the pattern in the terms. The common difference in this case is 4, and the first term is 3. So to find term sub n, here's our formula. The first term, 3, plus 4 times n minus 1. You will find sometimes in your answer key in your book that this gets simplified. 3 plus, and this 4 distributes through the brackets. 4n minus 4 would give you, if you simplify, 4n and collect like terms, minus 1. So any term in this sequence can be calculated by saying 4n minus 1. So if I want term 5, it's 5 times 4, subtract 1, 19. Okay, over the page. And let's do a bit of work with this. Okay, so here's our formula. We're going to keep using it, so let's keep track of it here at the top. Okay, for this arithmetic sequence, -3, 2, 7, 12, ... determine each term. Can we find term 10? Well, let's start off by coming up with a formula for any term, for the nth term. Term sub n is term 1 plus d times n minus 1. Okay, so I need to know what's term 1 for this sequence? -3. What's d for this sequence? Take any term, I'm going to start with 7, and subtract the previous term. We got 5. Formula for t sub n is term 1 plus d times n minus 1. -3 plus 5n minus 5, or 5n minus 8. Okay, so here's my formula for any term in this sequence. What's term 10? Well, term 10 would equal 5 times n minus 8. What's term 10? 42. Yep. Good question. Why is it n minus 1 and not n? I'll go back to the example where we developed this. When we start at term 1, if I wanted to know what term 1 is, I say 3 plus the difference times 0 for the first term. If I want to know what the second term is, I say 3 plus the difference times 1 for the second term. Because I'm starting at my first term and I'm adding the difference once. Oh, it's this example. Starting out the first term, adding the difference once to get the second term. If I wanted the fifth term, count up how many times I add the difference to the first term. So the fifth term, 1, 2, 3, 4, 5. So getting to here, I'm going to add the difference once, twice, 3 times, 4 times to get to the fifth term. That's why it's n minus 1. It's a really important question. Make sure that you understand that concept. Yeah.
For the question that we did for example 8.
Here?
I did a different way, but I got the same answer.
Okay, so tell me what your way was.
I did t10 equals -3 plus 5.
Okay.
Bracket n minus 1.
Equals -3 plus 5 times 9. And you got the same answer. Perfect.
So you don't have to use
You
that.
don't have to take this and write it in simplified form. You can do it that way as well. Just which way do you prefer? If you're going to do a whole pile of them, like we are, then probably this is a bit easier. But it's really neither here nor there. Okay? So why don't we use his method for this? Term 214 is equal to term 1, -3, plus common difference of 5 times n minus 1, 213. And guess what? You get to use a calculator. Why is it 213? 214 minus 1. Yes. Okay, plug it in your calculator. Tell me what you get. And I'll do this by hand.
1,13,5.
Okay. So brain speeds calculators. Okay, would you please do this one on your own?